Understanding key BGP attributes. I have two younger brothers who are hardcore gamers, and their games are not like the games of my generation. Their games require monthly subscription fees, days and days of gameplay to actually build a character who's worthwhile to live in this game. So you can see I've got Lith Knight the Merciless, who is a level 28 Sith Marauder with strength, presence, aim, all of these attributes that essentially make this character who he is. BGP routes are actually not too far from this. So essentially, when you receive routes from an upstream neighbor, so let's say we've got a carrier up here who sends you thousands of routes. This is your router. You need a way to be able to decide which of those routes are best and make their way into your routing table. One of the key ways that you do this is by looking at the characteristics of the route, or technically the BGP attributes of the routes. Those BGP attributes are divided into two major categories. You have well-known, or essentially standard, attributes that are supported by every vendor router who can claim to run BGP, right? So Cisco and beyond. And you have the optional attributes, or essentially the proprietary ones that people add into the mix. Now, going a little bit further, the well-known attributes fall into two major categories: mandatory and discretionary. You'll want to know this. Take a look at this route right here, 150.1.1.0. You can see that we have the origin, AS path, and next hop. Each one of those is a well-known mandatory attribute, which means it has to be there. If I'm going to receive this route and it's going to be even processed by me as a BGP router, it must have the origin, which is where did it come from? And that can be one of three things. One, it originated from an internal protocol, an IGP. It could have originated from an EGP, which, by the way, this is never used in today's world. That references the original EGP protocol. Like before there was BGP, there was EGP, which nobody uses that anymore. So just think of that one as gone. And then the last origin is a question mark. Like, I don't know where that route came from. It shows up as a question mark if you actually add those to the BGP table by using redistribution, right? The AS path is what autonomous systems has that route pass through. So essentially, as you've got BGP running up here, here's autonomous system 10, maybe that's where it originated from. It sends it to autonomous system 11, goes to autonomous system 12, and finally reaches your autonomous system, which is 500, right? The AS path of this route, if it actually originated from up here, would be 10, 11, 12, oh, actually I just did that backwards, 12, 11, 10, and then it would have the origin code, this one right here, of maybe a question mark because it was redistributed into BGP from autonomous system 10. That would be an example of an AS path. If that was missing, it would not be considered a valid route. Now you might say, well, what's the big deal with the AS path? Well, believe it or not, this is the key loop prevention mechanism of BGP. Let me ask you this. Is the internet redundant? I know this. It's like, yeah. There's redundant paths everywhere. So what happens when you have neighbor relationships that form like this and like all these, redundant paths? Well, you're going to get routes looping around all over the place. Well, the loop prevention mechanism that BGP has is if a router receives a route, it looks at the AS path and says, is my autonomous system listed there? So if this router receives a route, it's going to say, do I see autonomous system 500 in that path? If so, then I'm going to immediately drop it, and this happens all the time, because it's a looped route. It at some point has passed through my systems and happened to make its way back to me. No biggie. I'll drop it and move on from there. Right? So another final mandatory attribute is the next hop, meaning this is how you get to the next hop address. These two, and this is how you get to the next hop to reach that route, right? So if this ISP was passing it to me, he would be the next hop that I would go to reach that route. These two down here are the two discretionary, meaning they're well known, everybody supports them. However, the local preference, which is a way that you can tweak the preference or authority of the route to make him a stronger route or a weaker route in your system, and you can prefer one over the other, or the atomic aggregate, which is who summarized a route if we are receiving a summarized route from another autonomous system. So these are the two discretionary, which they're well known, supported, but they don't necessarily have to be in that update. These attributes, combine them all together, are the well-known ones, and they are not only functional, like now I know how to get to the next hop address, but they're often used by BGP's route selection process. Well, that brings me into BGP's path selection process. So here's the landscape. we've got a couple routers sitting right here in our little autonomous system. Maybe we are an ISP ourselves, right? We've got our own customers connecting into our system, and we are providing them internet access through all of our uplink carriers. You know, here are all the other autonomous systems that we're linking to, right? So we're receiving, essentially, if we've got 4 upstream ISPs, right, then we're going to receive a full copy of the internet routing table from all 4 of them, and our routers need to figure out which one of those routes are best. As in, let's go practical, which one of these uplink carriers would be the best to reach google.com? Well, the BGP route selection process is going to decide that for us. So all these routes come in. The first thing that's going to be chosen as the key attribute to break the tie. So again, I don't know why I keep thinking of World of Warcraft. You got your little character right here. Here's all the attributes, but instead of a character, it's the route 150.110, right? So we've got this route. What is the number 1 attribute that's going to win? It is the weight. Now, you didn't see weight on the previous slide because it is a Cisco proprietary attribute. Now, I know it's kind of like, well, just like Cisco to put theirs at the very top, right? Well, the good news is the weight is all self-contained, meaning it's not advertised. So if I receive the 150.1.1 network from this guy, and, you know, it's received from here and received from my iBGP neighbor, right? That happens all the time. My router needs to figure out which one to choose. Now, if I, as an administrator, came in and said, you know what, I'm going to set the weight for all of the routes, or maybe just for the 150 route, to be higher for this ISP, then that's going to break the tie. This one ends up going into the routing table for this router. But the key is he's not advertising the weight to anybody else. It's all self-contained. That's why I say it's no big deal that we're using this attribute as the number 1, because it doesn't have to be an industry standard thing. You can just go on your Cisco router, do that, and be done with it. You don't have to be quote-unquote compatible. The second strongest attribute, you know, if we're going down our list, the strength attribute would be the local preference, and this one is an industry standard, right? You saw it on the previous slide. It is a well-known discretionary attribute that we can receive. So here's the difference between the weight and the local preference. Let's just say I receive the route 15.1.1.0 from this ISP, right? I can go into BGP. You can use a route map to do this. There's a lot of ways you can do this. And I can say, you know what? That neighbor has a weight of 500, right? So all of the routes from this neighbor would be tagged with a weight of 500. If I'm not using weight, which is the only one that beats the local preference, you know, so maybe this one ends up winning, all the routes coming in will be preferred from this guy. And then when I advertise this to my iBGP peer, I'm writing it twice for no good reason, and I advertise it over here, they're all going to have the weight of 500. So local preference is actually advertised within the system. Thus the word local, meaning once it leaves the system, the local preference is stripped off. But boy, did I have an impact by setting the local preference to 500, because all the routes that I receive from this guy get tagged with that, and then as they're advertised over to this neighbor's going to be like, whoa, that has a higher local preference than all my ISPs, so I will prefer all the routes from you, iBGP friend, and all the traffic will end up actually going out to this ISP as the preferred one when it's said and done. Right? Now, down and down this list we go. You can see the goal of BGP is to break the tie. It's going to say, okay, I prefer the routes that I originated, meaning if I'm advertising them. This one right here is huge. Shortest AS path, right? One of the required, the mandatory, well-known attributes is the autonomous system path. I described what that was just a moment ago. It's all the autonomous systems that the route has passed through. So if I've got 15.1.1.0 up here, and imagine I'm not using local preference at all, that's going to go through this, go through this, go through this, go through this, and reach me through this ISP. Well, it might go through this, go through this, go through and reach me through this ISP too, right? So essentially, every single one of the autonomous systems that it passes through puts its little stamp on this guy's card. Think of it like a passport, right? It's like all the countries this guy has been to, or all the autonomous systems that he has. So one of the key differentiator, one of the strongest attributes to break ties is the shortest AS path. So unbelievably, BGP is more similar to RIP than most people want to admit, because it really relies on hop count as one of the top differentiators. I mean, think about it. We don't usually set this as administrators or this because we have to get involved in tweaking that. This is something that's done automatically, so essentially the one right after it, or essentially the number one tiebreaker, is who has the shortest AS path. So what I'm trying to say by this is, imagine we bring up a BGP relationship right here and leave everything at default, right? We don't tweak anything. We are essentially leaving BGP to be treated just like RIP. It's going to be using hop count to find the best ways around the internet, where hops equals autonomous systems. And down and down and down we go. If the AS path is tied, it goes to the lowest origin, meaning internal is better than the eBGP tag, which is better than an incomplete origin. Remember, I mentioned these as another well-known mandatory attribute that has to be there. As we get beyond that, I'm going to leave that to the BGP series to expound upon. You can see once we reach step 8, or essentially tiebreaker number 8, it's going to do a maximum paths check. That's going to say, hey, are we doing any kind of load balancing with BGP? Because you know what? We've really gone to the point of random chance at this point. We're just going to pick one, because you notice if our maximum paths is set to 1, which means BGP is not going to load balance, it's just going to say, okay, which route did I learn first? And then finally, the final tiebreaker is, okay, who has the lower router ID? Which neighbor gave it to me has a lower router ID, which is essentially the name of the router. You win. You know, it's just trying to break the tie so it doesn't have to have 2 paths in the routing table. Well, that is all the BGP that Cisco wants you to know from a route exam perspective. Route is really geared around routing in the enterprise, not so much the service router. So they just want you to know what BGP is, know how to bring up a basic neighbor relationship and receive some routes. However, you and I both know there's a lot more to BGP than just doing that. I would highly suggest going to CBT Nuggets website, typing BGP in the search field, and checking out this BGP course, videos 2 through 8. You don't have to look at the full thing, just look through videos 2 through 8 to where you'll know a lot more about what BGP is all about, all the way up to using route maps to set all the attributes that we just talked about in the previous slides. By doing that, you will transform yourself into a powerful BGP ninja similar to Lith Knight the Merciless. I hope this has been informative for you, and I'd like to thank you for viewing.